Welcome to Manimated AI. In this video, we will learn the foundations of matrices, what they are, how they are structured, and how to operate with them, making it easier to tackle advanced concepts later. Ever wondered what a matrix asterisk really asterisk is? Stay with me, let's figure it out together. So, a matrix is a rectangular array of numbers or functions, arranged in rows and columns. This is a 2 by 3 matrix. It has 2 rows and 3 columns. This is a 3 by 3 symbolic matrix. It has 3 rows and 3 columns. We can identify each element by its position, like a 2-3, meaning row 2, column 3. This is a 2 by 2 matrix that contains functions, such as exponentials and polynomials. This entry, e to the power 6x, shows that matrices can include expressions, not just numbers. This is a 1 by 3 row vector. It has only 1 row and 3 columns. This entry, a 2, is the second component of the vector. And this is a column vector. It has 3 rows and just 1 column. Here, 1/2 is the third entry of the column vector. Let us formalize what we just discussed about matrices. We denote them using capital bold letters like A, B, or C. An M by N matrix means M rows and N columns. Rows always come first. Each element has 2 subscripts. For example, a 2-1 means row 2, column 1. If the number of rows and columns are equal, we call it a square matrix. Two matrices are equal if and only if they have the same size and their corresponding entries are equal. Here are 2 matrices, matrix A and matrix B. They are both 2 by 3 matrices. Each entry in matrix A is equal to the corresponding entry in matrix B. Therefore, we can say A equals B. Now let's compare matrix A with matrix C. They have the same size but different entries. Notice how the second row, second column entry is different in matrix C, so A is not equal to C. To add 2 matrices, they must be the same size. If their shapes don't match, we can't add them. For example, adding a 2 by 2 matrix to a 2 by 3 matrix is not possible. Matrix addition follows 3 important rules. It is commutative, associative, and has an identity element. Here's A and B side by side. Let's compute A plus B and B plus A. As you can see, both give the same result, so A plus B equals B plus A. Now let's look at matrices A, B, and C together. First, we add A and B, then add C. This gives us the left-hand side. Next, we add B and C first, then add A. This gives us the right-hand side. Since both results are the same, we have proved the associative property. Now, let's look at the identity matrix. Here are matrix A and a 0 matrix side by side. When we add the 0 matrix to A, the result stays the same. So, this proves the identity property for matrix addition. Scalar multiplication means multiplying every entry in the matrix by a number, called a scalar. For example, multiplying matrix X by 3 scales every element. Here are the rules of scalar multiplication. Let's prove a few of them. Here's matrix A. Multiplying it by 1 gives the same matrix, so 1 times A equals A. Let's prove the distributive property. C times A plus B equals C A plus CB. Let's take A, B, and scalar C equals 2. On the left-hand side, we first add A and B, then multiply by 2. On the right-hand side, we multiply each matrix first, then add. Both sides give the same result. This proves the distributive rule. Let's prove the associative scalar rule. C times D equals CD times A. Let's take C equals 2 and D equals 3. On the left-hand side, we compute D first, then multiply by C. On the right, we multiply C and D first, then apply it to A. Both sides give the same matrix, proving the associative rule for scalar multiplication. Before we wrap up, here's a lightning recap. We saw what a matrix is, its shapes, how to read it, and the basics you can do with it. Get ready. Next, we are going to learn matrix multiplication. Is your gateway to visualizing linear systems. So, let's learn how to solve them step by step. Thank you for watching. Don't forget to like, share, and subscribe, and we will see you in the next episode. Stay tuned. This video is made by Astha Joshi. Keep learning, and I'll see you in the next video.